Getting ready, setting some experiments up here. Experiments with liquid nitrogen and butterfly wings. Let's see here. Got to get in my office. Okay, it's a mess, isn't it? Look at that. That is a mess. That's what it looks like when you do a bunch of experiments. Here's the butterfly wings right here. And now I'm going to head in the lab, get some liquid nitrogen. Let's see. There's my container. I hope I have some. Boy, that would stink if I didn't have any left. Oh yeah, we got a little in there. Not much, but we got enough to do some experiments. Hey, hello. Y'all are gonna have to bear with me. This is my first time going live. So I'm gonna have some trouble figuring some things out. Figuring out how to get to the comments might be a little tough for me. Hold on, let me look at this. Okay. Okay, there we go. Got it. Hello. Who's this? Joe GX. Thanks for joining in. We're going to do some experiments today. A little bit of liquid nitrogen here. Here's my tank. Whoop. There's my tank of liquid nitrogen right there. Got some butterfly wings we're going to mess around with. These are blue morpho butterfly wings. They are beautiful. Very pretty. They shine, they shimmer in the light. And that's not from a pigment, interestingly enough. The blue color is not from a pigment. These are full specimens in here. Well, I haven't even opened these yet. Yeah, you can see there, that's the full butterfly specimens that I have in this box. We might look at those a little later. Here's where a lot of it happens. There's my Tesla coil. I want to mess with that a little later, but here's a bunch of junk in here. Man, I got a ton of stuff in here. I gotta get some, oh. Nope, I don't see my styrofoam. Oh, there's my styrofoam cup up there. This is where I get my liquid nitrogen in. Okay. A little smaller cup. You know what? I am gonna go get my tripod. I'll make things a little easier on me. Okay, here's my, this is the hall. I do my work in. Here's my office. It's a mess. It's a mess, because, right, creative genius, you need mess. Oh, I always do this. What did I come down here for? My tripod. My tripod. Hey, hello, Astro G. What's up? Good morning, Chartreuse Maiden. Here's my tripod. I'm going to show you guys my Lego periodic table. We built this a couple years ago. It's pretty cool. This is full-on nerd here. Check this out. We had a bunch of kids come to campus and build this. So look at that. That's my Lego creation that deals somewhat with the particular element. Let's see. Yeah, you can see right here, iron. Iron Man on iron, of course. Of course. All right. Chemistry's the bomb. Who's that? You're going to have to forgive me. I think I saw the name was Baya. My eyes aren't so good. Oh, good thing I reminded myself of that. I'm going to need some eye goggles. I'm going to be working with my liquid nitrogen. Let me get this pair here. All right. Got my tripod. This will help things out a bit. Make it a little easier on me. All right, back to the experiment room. Okay, we'll set up the tripod here so you can see what's going on. There's my tank of liquid nitrogen right there. Yep, we're gonna pour some of that into that styrofoam cup on the floor and do a couple experiments. I probably should get a, probably a styrofoam bowl too. Yeah, here we go. Bowl ready. All right. Got my bowl here. Some nitrogen in here. Pour a little in. Just cool stuff. Whoop! That happens. See if I can't get this just right. Yeah, this stuff is cold. 77 Kelvin. For those of you who aren't familiar with the Kelvin scale, it's minus 196 degrees Celsius. If you're not familiar with the Celsius scale, minus 321 degrees Fahrenheit. That's some cold stuff. Looking right down in there. Yeah, let's pour some into this bowl. Right in here. You can hear it popping on the ground. Here, let's throw a little on the ground. You can see it here. Isn't that cool? That pop you hear is the liquid rapidly going to a gas. All right. All right, here's our setup. Let me pause a little bit and look through some of these comments here. I've been busy working for a while. Oh, I'm glad to hear, Maxim. You got a nice evening. We are in the, what are we about, 10 o'clock in the morning here. Oh, I'm sorry, folks. I'm having trouble finding these, going back and scrolling through the messages. Dang it. I'm clicking the little icon here. Hey, thanks, Thomas. I appreciate it. I'm clicking on this here. I just can't seem to go back and look at the past comments. I apologize. I will try to learn how to do that later. Maybe someone can pop a comment in and teach me how to do it. Oh, I'm an old dog. Trying to learn new tricks. Okay, this is kind of cool. We got these blue Morpho butterfly wings, right? You see those there? They got that nice shimmering color. And what's cool about these is they, that blue color that you see, it's a, Sally, it's a wing from a blue Morpho butterfly. Here, let's pull one of these up so you can see. These specimens I bought from the Butterfly Company. As you can see here, it's sky blue Morpho butterflies. So here's the Butterfly Company. You can purchase those online. I don't get any payment from these. This is just where I buy them. So I'm not doing any advertising for them. This is just me doing experiments that I love to do. So here's a blue Morpho butterfly specimen. Let's open this up and check it out. See what it looks like. So you can see when their wings are closed, you know, they might look like a moth or a normal looking butterfly, but when we open these, let's open these wings. Look at that. That's just gorgeous. They're very fragile. I'm probably going to break the wings. Isn't that just beautiful? And that shimmers in the light. Those wings are going to shimmer in the light. And you might guess that these wings, come from a pigment or a chemical in the wings. Excuse me, I should say the color in the wings come from a pigment or a chemical in the wing. But that's not what's going on here. The blue color actually comes from tiny microscopic structures in the wing. You can think of them as like fingers. They're called lamellae, so they're little protein structures. Thanks for watching, Maxim. So they're little protein structures, and what happens is light impinges on these protein structures, and it interacts with those structures, kind of like a diffraction grating. And it turns out that the light that impinges on these wings, the blue light gets amplified, and all of the other colors of light don't. They destructively interfere and cancel out, while the blue light constructively interferes and gets amplified. And that's why this looks so beautiful. That's correct. Bluebirds, chartreuse also show a similar kind of effect. There's a lot of species that do this. I forget the term. Here I'm giving a show and I can't remember the particular term. Structural. I think it's called structural color rather than color from pigmentation. Hi, Zafkel. Glad to have you along. Now, what's cool about this is these structures. Glad to hear it, Tracy. I've seen you on before. Thanks for commenting. So these structures, they call them lamellae. In between the structures, there's air. And so as the light impinges on these structures, it not only interacts with the lamellae, but it also interacts with the air in between. And what I like to do with the liquid nitrogen is I like to fill, interesting, Pindo. Zafkiel. The recap of this is we are messing with blue morpho butterfly wings. So let me just show you this. It's a special type of butterfly. These live in the rainforest. And here's a specimen here, a full specimen. All right. And, you know, their wings are closed. It doesn't look like much, but you open it up and it's just this beautiful blue color. And I almost dropped it in. And the blue color, there it is. I love it. Batty Botanist, I love that icon. So thank you, Thomas. Appreciate it. And what we see with this blue color is it comes from structural, like protein pigments. They're microscopic on the wing. And I just kind of try to model what they are with my hand. These structures are a little piece on my finger. They call them lamellae, and they're like tree-like structures that sit up off of the wing. And as light impinges on these structures, it interacts with the lamellae, such that blue light constructively interferes with itself and gets amplified, and all the other colors cancel out. They destructively interfere with each other. And in between the structures, there's a little bit of air, and that air also affects how the light interacts with the wing. So what I like to do is soak these in nitrogen, because the nitrogen, the liquid nitrogen, then fills the lamellae, and it changes the way the light interacts with the wing. See that color shift? Let me see. Let's see. Oh, look at that. Come on now. Look at that green color. It's just so cool. And now I want to pull it out, but I mean, I could do it with my fingers, but YouTube might not like it if I do that. So let me go get a pair of tweezers so I can pull them out, and you can watch what happens. Hey, damn it! I saw you earlier. We were talking online a little bit. Anyway, I want to pull some of these out so you can watch what happens to the color as the liquid nitrogen evaporates off. Well, let's just throw a couple more in here because it's kind of pretty. You know it is. Look at that. Gosh, it's so beautiful. That color is just this shift to aqua. Look at that. At this angle, it looks kind of green, right? And then as I shift over here, it looks a little more aqua. So not only does the color depend on, you know, what's in between the lamellae, it also depends on like the distance between the lamellae. It depends on what's in the lamellae, and it also depends on the angle of the light that is perceived. So you can see at some angles it looks a little more blue, and at other angles it looks a little green. I like the green. The green is my favorite when I get to see that shimmering green. And then here is, you know, what they look like without the liquid nitrogen. So I'm going to try to do is get a, there we go, the camera just a little bit on the tripod. Forgive me. Tighten her up. Otherwise, everything's going to fall off. There we go. Okay, back at it. We go get a pair of tweezers. We can pull those out. Here's the hallway. We're going to head into the lab. I'll let you see my office here, which is a mess. Thank you all for helping me get that thing right there on the wall. I'm very, very proud of that. And thanks to, all of you who subscribe, helped me get that. That was really cool to be able to get a Silver Creator Award. Yeah, damn it, I am a teacher. I teach at a small university. I teach chemistry. Here's my lab. A lot going on, so it's a little messy. I'm a little embarrassed by my lab, but what do you do? There's some tweezers here. All this stuff I use for experiments. I'm always messing around. Okay. And we'll head back. I'll let you see, once again, we'll let you see my Lego periodic table. We built this, I think, back in 2010, 2011. And then tell me your favorite element. We'll zoom in on it. Anybody got a favorite element? In the comments, let me know. Well, you know my favorite element. Technetium, baby. Why do you think I got the Hulk there? Technetium gives off gamma rays. Maybe you can make the connection, huh? Cadmium, all right. Is that, yep, damn it, says cadmium. So let's see. Cadmium is found in batteries. Yep. So someone just asked, sorry I missed your name, it started with a D. Someone asked what's the color of copper sulfate. Well, let's go get some copper sulfate, huh? We'll check it out. I got some right here. I'm messing with that. I've been doing experiments with copper sulfate. Let's see, where's my bottle of copper sulfate? I may have to go into the stock room to get it. Oh, here it is, no. So here's the copper sulfate. Yep. I'll just put this down here. And we'll check it out. Isn't that gorgeous? Look at that beautiful blue color. Some copper sulfate. Do a lot of experiments with that. If you go through my recent shorts videos, I have a video where I use a solution of copper sulfate to actually bust open a soda pop can. We're going to do a, let's heat up copper sulfate. Maybe in a bit. Maybe in a bit. Oh, bummer. Well, here. This is what I want you to argue with your teacher then. If you wrote that it was green, just say, hey, I was thinking of what happens when you put it in water and add a little chloride ion. See, this is some copper sulfate solution to which I added some chloride ion, and then it turns a green color. Of course, that's not due to the copper sulfate anymore, but see if you can get away with it. All right. A little research I did. I do research on the Coke and Mentos experiment. I love that experiment. All right. I wish I had you as one of my students, Maxim. Fun times, man. Just, interact with matter as much as you can. You know what I'm saying? That's what chemistry is about. All right, let's pull some of these out of the solution, the liquid nitrogen, and watch what happens. I want to get the angle. To my eye, it's looking a little green. I'm going to try to help you all see a little more green rather than... There we go. There we go. All right. Detonator, I don't know if I know the answer to that. The difference between soap and detergent. You're going to have to forgive me. I'd have to probably look that up. So sorry I can't answer your question. Let's pull one of these out and watch what happens. Oh, that focus is horrible. Sorry about that. Let's put that down there. And look at that. You see, as the nitrogen evaporates off, it goes back to the blue color. Let's pull another one out, stick it down here, and see, watch it happen. not getting that blue like I'd like. Let me just change the angle just a bit. It is blue now, baby. That's some cool stuff. I love this experiment, especially as we can watch that nitrogen just kind of evaporate off. Hi, Masons 4455. Isn't that beautiful? Come on now. Watching that nitrogen evaporate off. Thank you, detonator. Although I'm not doing it, it's just nature doing its work. You know what I mean? I'm just setting it up. That's what's nice about science. You know, the art is already there. You just got to set and then watch it happen. Gosh, that's so cool. And it goes and back to green. Oh, man. I love it. I love it. So let me pull out, I'm going to pull out a diffraction grating to give you guys a little idea of what, is potentially happening with the blue morpho butterfly wings. I know, I work all the time with liquid nitrogen. Would it turn green when put in water too? Well, let's find out. Come on, let's find out. I gotta go get some water though. Gotta go get some water. So we gotta make another field trip down to the lab. And I'll tell you what, I'll get some other liquids too, in addition to water. Wait, I may have them all here. Indeed, science is life, baby. I'm just looking to see if I have some alcohol in here, which I may. I do not have strontium metal. Why? What do you do with I have calcium metal. I mess around with calcium metal. I have a couple. Here's some water. I have a couple videos on calcium here, and I want to get some alcohol also. Do I have alcohol in here? Well, I'm gonna need to get a dropper anyway. So, yeah. All right. Let me go get a dropper and some alcohol, because there's some cool things you can do with that as well. And remember, what we're going to be doing here is we'll be adding fluids other than liquid nitrogen on those blue morpho butterfly wings. And those liquids, we're going to see, remember the lamellae on the surface of the wings, that's kind of what gives it the color, plus the whatever's in between the lamellae. It's usually air, but if you put liquid nitrogen in between the lamellae, you get a color shift. We're going to try to see what happens when we put water on the wing, and then I'm also going to see what happens when we put alcohol on the wing. And if you can get the alcohol or the water, to soak in between the lamellae, you're going to see a color shift. So I'm going to get my alcohol here. Well, 91% isopropyl. So this is mostly alcohol. 91% of this is alcohol. The other 9% is just going to be water. And then I'm going to get some droppers here, so I can just drip a little bit onto the surface. All right, here we go. Thanks for the suggestion. Anything else you all want to see in this, boring science building? Or okay, back to the experiment room. I may have to tighten up the camera here again. I'm doing a lot of moving around. All right, back at it. Holy cow. A bunch of comments just came through, folks. Give me a second, okay? I want to just look through these a bit. Let's see. I'm having trouble seeing them. Well, sorry about that. I've lost them. Okay. Well, here, we'll get to the experiment. Here's my blue morpho butterfly wings, and the question is, what happens? Oh, there we go, like that. I see how to do it. Oh, so Chihuahua let me know. Thank you for teaching me this. Soaps are salts of carbonic acid, and detergent are sodium or potassium salt of sulfonic acid. I think you are correct there. So to make a soap, you react glycerol with sodium hydroxide. I know that's one way to make it. And so indeed, you end up getting a sodium salt of a carboxylic acid with a really long carbon chain. but that's correct. The detergents have a sulfonic acid at the beginning. Alcohol detonator is not basic. It is considered to be neutral. Damn it says we should try warm alcohol. You know, buddy, you gotta slow down on the on the suggestions here. I'm just trying to keep up. Can I make an oscillating solution, Zafkiel? Yes, I have done that. I have made an oscillating solution. If you go through, and I have a long form video on this and also a short form video on this, I have to tell you that learning about oscillating chemical reactions it's complicated. I've written an article about this that you can check out in the Journal of Chemical Education, and you can learn about this, how reactions oscillate in a fairly simple manner. But you're going to need a little bit of calculus, just a bit. You're going to need to understand a little bit of calculus and quite a bit of algebra to be able to nail it all the way down, just to get a basic understanding of how those work. Okay. All right, let's get back to doing some experiments here. So, somebody want to know what happened when we put water on these wings? Here we go. Get some water. Add a few drops. Beads up on the surface. Isn't that cool? So what in the world? Why is it beating up on the surface, whereas the liquid nitrogen, that just soaks all the way down into the wing? It soaks in there. Let's see what happens with the alcohol. So here's the water, and now we're going to try the same thing with the alcohol. See if we see a bit different or the same. Look at that. Come on. See a little shift to green. And it doesn't beat up. It soaks in. Thanks for watching there, Maxim. Appreciate you hanging out with us this morning. So again, here's a difference. Let's drip a little water on there. This wing here. That's exactly right. Zafkiel. The water has a high surface tension. And we've got to remember that these lamellae, right, in order for the water to soak into the wing, it's got to penetrate the lamellae. But water has a high surface tension, which means it takes a lot of energy to get it to spread out. Tracy, my guess is that this is a protective effect on the butterfly, that it keeps, because these live in the rainforest. I'm not a biologist, so don't quote me on this, but my guess is that these that is so freaking funny, Mocha. Oh, geez. Anyway, so the water, in order to get into the lamellae, to penetrate it, it has to spread out, but it takes a lot of energy for water to spread out because water has a high surface tension, and so it doesn't work. Oh, that's the alcohol. So I'm dripping alcohol on there, and you can see when I add the alcohol has a low surface tension, so it can spread out into these lamellae and penetrate and cause the wing to soak. But on the water, it does not. So yeah, thanks for that suggestion. Damn it, that was a good one. Gave us a little experimenting to do. We can even watch this. Let's see if we can watch this evaporate. It takes a lot longer for alcohol to evaporate than for liquid nitrogen. And you notice is that when it's soaked in the alcohol, you do get like a green color. It's not quite as vibrant. Well, maybe it is. I mean, look at that over there. That's actually looking better than what I saw in the nitrogen. Well, but it does take like a lot longer for the alcohol to evaporate away. I'm going to try to speed this up maybe by blowing on it. Let's try this one over here. See if I can get the alcohol to evaporate away. So I'm blowing on this wing, trying to get the alcohol to evaporate. Sure enough, and you can see as the alcohol evaporates away, air returns to the gaps in between the lamellae. And that blue color returns. It's taken a little while because it takes a lot longer for alcohol to evaporate than liquid nitrogen. That's actually a nicer effect, or at least it's showing up nicer on the camera. One thing I also noticed with the alcohol, did you see sort of the red tinge? Just a little bit. I noticed that a lot. Hey, thanks for watching that Darth Vader video. We are loving it. I'm going to try to you all share that one on May the 4th, all right? And Revenge of the 5th. Indeed, science is like magic. I like to say that the difference between science and magic is a scientist should at least always tell you how the trick they're doing works to the best of their understanding. Chihuahua, I have made a nitrogen triiodide before. Not going to pull that off this morning, though. Looks a little more brown, I agree. There's like a brown color to it, but yeah, here in you can just see some tinges of red in the color. And now I'm trying to get more of the, well, chlorine detonator. It depends what you mean by chlorine. Do you mean chlorine the atom? Or do you mean chlorine, diatomic chlorine, Cl2 with 2 chlorine atoms stuck together? I mean, both of those are essentially very reactive. Chlorine atom, the atom itself, man, that wants to gain 1 electron like crazy, right? So that's going to be highly reactive. Chlorine itself, Cl2, chlorine is fairly what we say, you're going to have to apologize. I don't know how much chemistry folks know, but the chlorine atom is highly, it has a lot of electron affinity, which means it really likes electrons. It's going to try to grab them from wherever it can. And so, both the chlorine atom and chlorine and Cl2 are going to be looking for electrons. And, that's when chemistry happens, folks, when atoms and molecules gain, lose, or share electrons to make new ions or atoms or electrons. That's when chemistry happens. That's when chemical changes happen. And so any atom, any substance, I should say, that is looking for electrons or sharing them or gaining them or losing them, that's gonna cause some chemistry to happen. Yeah, in chlorine and Cl2, that's correct. In Cl2, it is a covalent bond. So in Cl2 with 2 chlorine atoms stuck together, that's going to be a covalent bond sticking them together. So AI Anonymous, what I'm doing here is I am taking, I have made I don't know what you mean by high-end explosive. And I don't know how to archive a live. This is my first time going live. Yes, it is a covalent bond in HCl. I will try to figure out how to archive this. If someone can maybe drop me a note in the comments, this is my first time going live. So what I'm doing is I'm taking blue morpho butterflies. Here's one here. Well, these are specimens. So here's one of the blue morpho butterflies. And you can see this is what they look like with their wings closed. And when they open their wings, this is what it looks like. And what we are doing is we are just studying the coloration that occurs on these blue morpho butterfly wings. Well, maybe you're right. Maybe you're right. Maybe HCl is an ionic bond. Somebody Google that for me. You guys are pushing me this morning. I love it. So anyway, we're looking at how the coloration happens, and we, if we were to look at this wing under an electron microscope, what we would see is a bunch of structures. if you look up how to archive a YouTube live stream. Thank you, Mocha. So, okay. Thank you, Mocha. I appreciate it. I'm losing I'm losing track of what's going on here. Okay, that's correct. All right, so I'm going to focus here on the wing here for a bit. So if we were to try to extract, say, a pigment from this blue morpho butterfly wing, like a chemical, we'd find that we can't do that. There's no pigment in this wing, but what we would see if we looked at this with an electron microscope is we would see little protein structures that I like to model using fingers. These little protein structures, they shoot up from the surface of the wing, and those protein structures are called lamellae, L-A-M-A-L-L-A-E. That's the plural of lamella. And these lamellae interact with light. So as light impinges onto the surface of the wing, the lamellae interact with the incoming light, and it turns out that the lamellae are situated, the distance between the lamellae and the whatever's in between the lamellae, which is usually air, they cause the light that is blue to get amplified, and all the other colors of light destructively interfere and get canceled out. So that's why the blue light is preferentially what you see on these butterfly wings. You get that beautiful blue color. So the blue light impinging on this, all of it, gets constructively added together and amplified. And then the other colors of light, those get destructively interfered with, and those get canceled out. And what's interesting about this is that if you put different fluids on the surface of the wing, if that fluid can spread out and soak into the lamellae, then you're going to see a color shift in the wing. Because instead of just air being in between, now you have a different fluid in here other than air, and that's going to just cause the way that the wing and the stuff in between the wing, the gaps in the wing, interact with light. So that's what I like to do. I like to fiddle around with this and see what happens if I put different fluids onto the wings and see what happens. So we'll just try a couple more here. So long, Ricky. Thanks for watching. All right, let me get this cleaned up a second. Wash this off. Are lamellae akin to scales? I am sorry, I am not a biologist. I think not, because they are so tiny. They are so really tiny. Bye, Zafkiel. Thank you so much for joining us this morning. I think scales are probably a lot larger. I know they're a lot larger. So here we go. Let's pop a couple wings here. Welcome. Glad to hear folks from India. I love my followers from India. Okay, I'm going to put a little water on this wing, this one here. Little drips of water. And you see the water beads up. And that's because water has a high surface tension. And because it has a high surface tension, it can't spread out and soak into all of the lamellae. Can't penetrate it, because it takes energy to get water to spread out, because water has a high surface tension. So that's why it beads up. But if we do the same thing with some alcohol, let's try it with alcohol. All right, here's my alcohol. A little alcohol here. Give it a shot, see what happens. Here we go. And look at that. That's so beautiful. Gosh, that green color. It is so pretty. It's just so pretty. And as it evaporates off, I'm going to try to help this evaporate a little better. I'm going to, it is beautiful, isn't it? AI Anonymous. It's just so pretty. All right, I'm going to try to dry it off to get the, the blue color to return. So I'm going to just pat it dry here. There we go. There we go. And then I'm going to try to just, boy, that really soaks in there, though. I'm going to blow across the surface of the wing. Come on, that was cool. That was cool. What if you were to make a mixture of water and alcohol? That's a great question, and we're going to try it. I do want you to know that the alcohol I did add already is a mixture. It's 91% isopropyl alcohol. Piranha solution. I've never done an experiment with piranha solution. Maybe it's something I need to try at some point. But anyway, this is a 91% isopropyl alcohol, which means this is, obviously 91% isopropyl alcohol, and the other 9% is water. But we can try. Let's try it. Let's try mixing like a 50-50 mixture of these two, see what happens. So this isn't going to be like real careful mixing here, but let's give it a shot. See what happens. You know what I want to do? This is what I'm curious about. Let's try this. What I want to do, I'm going to take a bunch of water, all right? Let's just put a bunch of water in here, about that much. And then what I'm going to do is I'm going to add drops of alcohol to see how many drops of alcohol it takes. I've never done this before. This might be something I'd have my students do, now that I think about it. So I'm going to see how many drops of alcohol it takes to make it where the, sorry about that, to make it where the water will penetrate into the wing. Alcohol it will dissolve, but it doesn't dissociate in water. So remember the difference between dissolve and dissociate. Dissociate, that conjures up the idea that it's going to split apart into ions. And alcohol doesn't do that, but it does dissolve. I'm going to add 1 drop. I don't think that's going to be enough. No way. Curses, I don't have enough. I think this one's okay. All right, so there's no way 1 drop's enough. Yeah, so 1 drop didn't do it. Let's add 2 drops. I want to make sure this is alcohol here. Hold on a second. Just want to sniff that, make sure it is. Yeah, it is. Okay. So let's add 2 drops. See if 2 drops is enough. 2 drops. Boop. Swirl that around. See if that does it. Nope. We'll go a little quicker. 3, 4, 5. There's 5 drops. See if that's enough. At what point will I add enough alcohol to get it to penetrate? Not yet. Not even close. You know what? I'm going to add a full squirt. I'm not a very patient man. Okay. So this is going to be, what does that look like? About, I don't know, a milliliter or so. Just pop it in there. Rifle that in there. I still don't think that's going to be enough. Hey, Kabir. Glad to hear you're here. Love my followers from India. I hope you're following. Yeah, I hope you all decide to follow the channel and let a few folks know about the kind of goofy stuff I do. If alcohol is neutral, then why does it form a salt when it reacts with an acid? You know, well, that's good to hear, AI. Let's add a whole nother squirt. I'm not an organic chemist, but I think I remember that alcohols and acids, when they react, they make esters. Add another full squirt. Oh, many are from Bangladesh. Interesting. Well, thank you. Thanks for joining in from Bangladesh. Hope things are going okay over there. I'll clear that off. Nitroglycerin. You know, you can look. Thanks, damn it. Thanks for letting me know. Glad to hear there's a lot of you from Bangladesh hanging around. I do some experiments with nitrates. I tend to try to use really simple experiments. We're getting close now. Tennessee, Chartreuse. I got a sister that lives in Tennessee. That, you can tell, the drop here is starting to look a little flatter. So we are getting close. And I think I can even see a little bit of green color. Maybe that's just something I want to see. But come on, man, that looks a little bit green to me. I'm not sure of it, but I do see as I here, let's try to move around. Let me try to move the angle for you, because the way the light impinges, that's looking a little, okay, Zafkiel believes me. It's okay if you don't. All right, folks see it too. That's kind of cool. This is a cool experiment. Thank you for the suggestion. I forgot who suggested to try a mixture, but I think this is a really interesting. The light is reflecting on the drop along with the wing. Yeah, 5 drops. Cesar, it's not 5 drops. I've added 2 full squirts at this point. I've added 2 full squirts of alcohol. It is kind of cool. I think I'm going to add 1 more squirt. Let's see what happens. Let's just check it out. 1 full squirt here. I'm going to back up the camera just a bit because, yeah, that's a little better focus. All right, here's another full squirt. And I'm saying that's about, I don't know, 10, 15, 20 mils. So guessing, I'm going to say this is about % alcohol. Let's see. It's about 2 mils per squirt. So this will be 6 to 15. Roughly 25% alcohol is what we'll be at here. Roughly. I mean, I'm just, let's get that mixed up. Yeah, I don't mess a whole lot with mercury detonator. I'm a sloppy enough chemist that I know that I probably shouldn't. Samurai, I teach chemistry. So yeah, I'm sloppy enough that I don't mess with things that require real careful use. Oh, Elizabeth, welcome from Ohio. Just a little bit, really close to you. Really close. Yeah, look at that. As I dried that off, you can see there's something that was able to get into the wing there, right? Look at that. You know, Chihuahua, I don't know how luminol is made. I really don't. That's a great question. Someone Google that and teach it to me. I don't know how luminol is made. I have some in my stock room, but I don't know how it's. Is that salt? Are you asking, is this salt? No, this is alcohol that I'm adding to the water. Here we go. So a little drop here. And there it is. About 25%. Roughly 25%. I'm going to put one of my students on this project, actually, to find out what % of alcohol does it take to finally cause the alcohol to penetrate into the lamellae. I think I'd have a couple students that might be interested in this. Oh, salt on the wing. I'm sorry. I don't think it's salt on the wing. All right, I'm going to blow this. Yeah, Mocha, I'm planning on, as much as I'm able to have Sunday morning science, maybe Sunday or Saturday morning science. Just be looking for it. Try to do it. I've got a lot going on in my life, so, there may be some weekends I can't pull it off. We'll do this for about an hour. I'm blowing on it right now to see if the green color goes away as the alcohol evaporates. Yeah, it is morning over here. It's what is it, about 11 o'clock? And hey, if hey, Canada Wart, I'm doing an experiment. I'm doing an experiment with what are called blue morpho butterfly wings. So If you look up the butterfly emoji on your phone, you might see, this icon. So this is, it's a species of butterfly that exists in the rainforest, I think in South America. And these butterflies, here's a specimen right here with their wings closed. They just look like any ordinary butterfly. Maybe they look like a moth. But there it is. Love that emoji, man. Thank you, AI. But when they open their wings, it looks like this. That's correct, Game Boy Genius. This is one of those butterflies that has that nanostructure. And so, as Game Boy Genius said, these wings do not have pigment in them. There's not a chemical that gives them this blue color. There are protein structures, little tiny protein structures, microscopic, maybe even nanoscopic, that are called lamellae. And these lamellae grow up off the surface of the wing. I like to kind of model them. They're tree-like structures, so I model them with my fingers. And in between the lamellae is air. And when light impinges onto these wings, it turns out that the blue light constructively interferes with the lamellae and the air and gets constructively amplified, and that's why we see blue color. All of the others, Game Boy Genius, the alcohol does not alter the structure permanently, and we're going to be able to see that. But the other colors destructively interfere and they get canceled out. And if you can change the fluid, air is a fluid, so if you can change the fluid that's in between, yes, Cesar, there are synthetic materials that use this same concept. So you can, like I've done experiments, you can do experiments where you heat a shiny copper coin at roughly, I think it's like 250 Celsius. You'll grow a copper oxide coating on the surface of the coin, and as the thickness of the surface grows, the color on the coin changes as well. You can look through some of my YouTube shorts, and you can see one of them. I think I posted it right around the beginning of this year, where you can see this effect happening. Anyways, if we can change what's in between the wings, in between the lamellae, we can change the color. So what I've got here is just a solution of alcohol, and the alcohol can, there it is, penetrate the lamellae and cause a color shift. See that green color? Gosh. Henry, what produces the color is the way the wing interacts with light. I'm going to check to see if I remove the alcohol. Does it change color by temperature? I do not think so, and there's an experiment we can do to test this, although I need to get some Petri dishes to try that. It's just diffraction, Henry. So there's these little pigments, not pigments, there's these little protein structures on the wing that act like a diffraction grating and interacts with light and causes these color shifts. And if you can get fluid, you're welcome, Henry, if you can get fluid in between those protein structures, as you can see here, alcohol has penetrated that, you can see a color shift. And now what I'm trying to do is I'm going to try to get the alcohol to evaporate, and we should be able to see the color return. Now, it takes a bit to get the alcohol to evaporate. I'm just going to blow on this wing. Boy, it takes a while. That's soaked down in there. That is soaked in there. Try again. There you go. It's a little drier. Camera shot, I'm just doing this for fun, man. I just love doing science. I love doing science experiments, and I'm really happy to see folks enjoying to do the science along with me. You can see it evaporating away? Come on now, that's cool. I don't care who you are. It is getting shiny. Henry, yes, we can use different solvents to get different colors. That's correct. The diffractive index of the alcohol is indeed involved. There is a article published in the Journal of Chemical Education on this particular experiment, and you can learn a lot more. Just go to the Journal of Chemical Education website and just type in the search bar blue morpho, and this should pop up. If you really want to get into the nuts and bolts of it, you know, the physics of it. Yeah, that's beautiful. That's really pretty. Oh, you know, I want to show you something. This is a little different. No, all butterfly wings do not act in this way. This is really, Chihuahua. I did a reaction on that. Go check out my YouTube shorts. You'll be able to see it. Can you show it under a microscope? That's a good idea. Unfortunately, I don't have one with me. Check out the liquid nitrogen that I used earlier. You see that down there? Isn't that fun? Y'all know where this snow came from. So this was filled with liquid nitrogen. I think there's a little left in here. Where'd the snow come on the outside of the cup? Where'd that come from? Oh, here, we can do that test. Does it change with temperature? Let's find out here. Yeah, I don't know how. They cost about $1 a piece, the butterflies do. So here I've added snow to the wings so we can test to see if, you know, the color changes based on temperature. And it doesn't appear to. Yeah, let's just pop it right on the cup. It does not appear to. Getting the color to change. Oh, the nitrogen fell out. But yeah, you know, cooling down the wings doesn't seem to affect. Yep, I don't see much happening either, damn it. Yep. So there you have it. Kind of fun. Oh, I got a mess to clean up. Look at all this. I have a mess to clean up for sure. But, you know, Chihuahua, I have a video of that already. I have a video of me putting my hand in liquid nitrogen. Go check it out. A couple of them. Any other comments? I think this has been fun. Yeah, thank you all for joining me this morning. I really appreciate it. So I think, you know, maybe a couple Sundays, couple Saturdays, be looking for this. Just look through and see if there's any more questions before I take off. We've been doing this about an hour. Yeah, be sure if you like kind of what you see here, consider subscribing to my channel. Thank you, Mocha. I had fun. Yeah, consider, you know, if you like science, you like goofy, simple science experiments. Yeah. Subscribe and maybe, you know, share my channel with others. Been great sharing this morning with you, and we'll look forward to doing this other weekend morning. So long, everybody, and I really appreciate you being here.